Okay, we did it. Snow day. Um, and thank goodness because I just woke up, looked outside, and it's bad. So good thing we're not around for that. Um, but nonetheless, we will learn. We've been talking about SOHCAHTOA now for a couple of days. One thing we were doing towards the end of yesterday's class is talking about how we can set up a trigonometric statement and then use that to solve for a missing side in a triangle. Now, when it comes to setting up your trigonometric statement, right, you have to have a name, you have to have you have to have a name, you have to have an angle, you have to have an equal sign, and you have to have that set equal to some fraction or ratio, right? The name that we use is either sine, cosine, or tangent, and the ratio is determined by the sides that that we're either solving for or that we know in the triangle, right? Now those sides names are relative to the angle that we're going to use. So we're using this angle right here, which means we start in that angle, we draw our line over here. This is the opposite side. We go to the corner of that right angle box, and that's going to point at this side, which is the hypotenuse, which leaves us with this side down here, and that would be then the adjacent side. So we're using, I'm going to erase this a little bit so we can see what's going on in here. We're using this 72-degree angle to solve for x, and x is the hypotenuse, and we know the adjacent side. So we have the hypotenuse, the h, and we have the adjacent side, the a. So when it comes to writing the name for your trigonometric statement, we need the one name, the one ratio that includes the adjacent side and the hypotenuse, and that's our cosine ratio. So we're going to write a cosine statement, cosine of 72, right? The name, the angle, the equal sign, and then the ratio itself, which is the adjacent side over the hypotenuse. Now, we talked about this one yesterday, but I'm going to expand on it a little bit. We're going to, as far as solving for x, right? So now at this point, we've written our trigonometric statement. We have to solve for x. It'd be completely understandable if you looked at this and said, I'm going to multiply by 6 because this is a fraction and there's a 6 in it. But multiplying by 6 doesn't clear the 6 that's on the top of this fraction. Okay, so multiplying both sides by 6 isn't going to get x by itself. It's going to make it even worse. Okay, so the one term that I like to use is the switcheroo. The switcheroo is a shortcut that works. It's mathematically correct, right? But the switcheroo is a quick shortcut that we can use to solve for x when the x that we're solving for is in the denominator. Okay, and what we do is we take that value of x and we take this entire trigonometric piece, this package here, and we swap them out. So if we do that, that would be x equals 6 over the cosine of 72. Okay, so we're not multiplying by anything. We're not multiplying by both sides. We're not dividing by both sides like we normally do when we're solving. We're literally taking those and switching them out. Okay, and just as a quick aside, like, why does this work? I know I've shown this to you guys before, but I'll do it one more time. Take a different, simpler equation like this. Okay, if I wanted to solve for x, I would have to get x out of the denominator of this fraction. The way I do that is by multiplying times x on both sides. Those will cancel. We'll have 3 equals 2x. Then we'd divide by 2 to get x by itself. So we'd get x is equal to 3 over 2. Well, if you go back to the beginning, when this x was down here, this is what this problem started like, right? And even ignore this, the process that got us there. What's the shortcut that gets us from this point to this point? We just swap these out. Okay, so that's the reason why the switcheroo works. Feel free to just use the shortcut. We can do this when the variable's in the denominator and we have a term or a sequence of, or an expression on this side that doesn't have any variables in it. And we just swap them out. Now all you have to do is plug this 6 over cosine 72 into your calculator. Let's do that. Just a reminder, again, that when you go to Desmos, immediately after you open it, you have to go to the wrench, get my ugly face out of the way, click on degrees. The calculator has to be in degree mode. So we have 6 over the cosine of 72. So we'll call that 19.4. So when we come back here, we get 19.4 for our final answer. Okay, so what does it come down to? It comes down to writing a trigonometric statement based on the information that's over here. You have to label the sides, and then you have to write a statement that includes the name, the angle, the equal sign, and the fraction. The name, the angle, the equal sign, and the fraction.